Hey there, my name is Dhaval Gupta and today I am going to teach you about moment of inertia. Let us understand what is moment of inertia. Here I have a wooden stick. Now if we try to rotate it like this, it is easier than rotating it by one of the ends. Here I can barely rotate it, but from here it is very much easy. So it is this is due to moment of inertia, as in this case the moment of inertia is very much less as compared to moment of inertia and in this case. So before explaining this, let us define moment of inertia. Moment of inertia is the property of an object by virtue of which it tends to stay at rest or in uniform circular motion until and unless an external torque is applied on it. Here torque is momentum of force. Torque is always perpendicular to the radius of to the axis of rotation. Now momentum of inertia can be found out by I equals to m r square, where I is the moment of inertia, m is mass of the particle, and r is the radius between the particle and the axis of rotation. So now let us derive the formula of finding the inertia. Now let us find out the formula of finding the moment of inertia of any rigid body. Here I have taken a rigid body with its axis of rotation as z-axis and having numerous particles. Let us assume 3 particles from this rigid body, which are P1, P2 and Pn. Now for the given rigid body, the moment of inertia of the rigid body would be equal to the sum of momentum of inertia of the P1 particle, P2 particle and Pn particle. So momentum of inertia for the given rigid body would be equals to momentum of inertia of P1 particle, which would be equals to m plus m, which would be equals to m into r1 square, where m is the mass of any particle in the given rigid body, as the mass of the particle in a rigid body is all equal, because the rigid body is made up of same type of matter. P1 particle momentum of inertia equal to m r1 square. Now momentum of inertia of P2 particle would be added to the momentum of inertia of P1 particle. So m r2 square. Now momentum of inertia of every particle in this rigid body would be added to find out the momentum of inertia of the given rigid body. So adding all the momentum of inertia of all the particles till p nth particle which is the last particle in the given rigid body, would be equal to sublimation of k equals to 1 to n m r k square. So we can find out the momentum of inertia of a rigid body by the given formula. Now then, there are two theorems of momentum of inertia. First is perpendicular axis theorem and second one is parallel axis theorem. So let us start with perpendicular axis theorem. Now then, let us understand what is perpendicular axis theorem. Perpendicular axis theorem states that the momentum of inertia along the axis perpendicular to the plane lamina is equal to the sum of the momentum of inertia along the axis perpendicular to each other on the plane lamina and which intersect each other at the point where the axis perpendicular to the plane lamina lies. So as you can see here, this is the plane lamina and this is the plane lamina. And the axis perpendicular to the plane lamina intersect the perpendicular axis on the plane lamina at the same point, and the momentum of inertia of the plane along this perpendicular axis is equal to the sum of the momentum of inertia along this axis and this axis. So let us prove perpendicular axis theorem. Now in the previous figure I have taken a point P which is at y distance from x axis, x distance from y axis. Now as PQ is parallel to AO and OQ is parallel to AP, so also angle AOQ equals to 90 degree. So we can assume that AOQP is a rectangle and we know that opposite sides of a rectangle are equal. So OQ is equals to X. Now as OQ equals to X, QP equals to Y and OP equals to R, and angle OQP is equal to 90 degree as it is a rectangle. Therefore by Pythagoras theorem the square of the hypotenuse, that is R square, would be equal to the square of the other two sides, which is x square plus y square. Now moment of inertia along x-axis of particle P would be equal to the mass of the particle P, let us assume it to be m, and the square of the distance between particle P and x-axis, which is equal to y square. Now similarly, along y-axis, moment of inertia equals to mx square. Also, moment of inertia along z-axis would be mr square. Now adding moment of inertia along x-axis and y-axis, would be equal to my square plus mx square, which would be equal to my square plus x square, where we have taken y square plus m square in a bracket and m as common from the previous one. Now this would be equal to r square, as r square is equal to x square plus y square. So we have to put the value of x square plus y square as r square. Now we know mr square is equal to moment of inertia along z axis. So moment of inertia along x-axis plus moment of inertia along y-axis is equal to moment of inertia along z-axis. And this proves the perpendicular axis theorem.